Hi there, this is Penelope. This is the first of the videos on force. There are 3 videos, I think, on force. This is for the Foundation Level 4 course here at WellTech. So, a force is a fundamental concept in all areas of physics, and a force is a vector, which means that it's got size and direction. And I remember before, when we've looked at these, we've used the word magnitude and we look at direction. And a resultant force, and again we looked at these in the vectors videos as well, a resultant force or a net force is produced when 2 or more forces are added or subtracted when we're using vectors. When a resultant force acts on an object, the object's going to accelerate in the direction of the resultant force. So we can give you some formulas here. The relationship between the resultant force, which is F res, and the mass and the object's acceleration is going to be F res equals m times a. Now this is the second of Newton's laws. If we're talking about gravity, then the gravitational force between some object and the Earth causes that object to have a weight force. So we can talk about the weight force and we can call it Fw, and that's the relation. We can show the relationship between the weight and the mass and the acceleration due to gravity, and usually we'll approximate gravity to 9.8 meters per second squared, or 9.8 meters per second squared, like that. So now we've got that the weight force is equal to mg. This is the first law. Now, Newton lived a long time ago, Sir Isaac Newton. He lived 1643 to 1727. He was English. He was an English physicist and a mathematician. And what he did was he discovered several relationships between forces and their effects on different objects. So the first of his laws is this one. That if the resultant force on an object is 0, then the acceleration is going to be 0. So an object with acceleration of 0 will either have a speed of 0, so it's not going to be moving, or it will have a constant velocity, so it's got a constant speed in a straight line. We also may call this the law of inertia. Some books talk about it as that. And it also implies that motion can exist without a force acting. Let's look at the skydiver, the picture of a skydiver there. Now the weight force of the skydiver is balanced by the air resistance. In the middle diagram, the 3 forces acting on an object are balanced because the resultant force is 0. And if you look in the other diagram there, you'll see if 2 equal people are pushing together on a box, nothing's going to happen. But if the 2 people are on the same side of each other, then it's going to go in that direction. Now, Newton's second law we looked at in the first slide. But suppose we've got a trolley that has, well, let's do the mass. The mass has a 1 kilo mass. There's weight hanging down here. There's a pulley here. And there's a trolley sitting on a bench. And there's a string that's attaching them. And the trolley has a mass of 3 kilos. And the question is, what will the trolley's acceleration be? and take gravity as approximately 9.8 meters per second squared and ignore any friction. So I've got the weight force down here. The objects that are going to accelerate are the 3 kilo trolley and the 1 kilo mass, because they're tied together. And because they're tied together, they're going to have the same acceleration. Let's look at the total mass that we've got accelerating. So that'll be the 3 kilo mass plus the 1 kilo mass, which would be 4 kilos. Now, the force that's causing the acceleration is the one that's acting on the weight. So it's the weight force on the block or whatever it is at the bottom. Okay, so let's look at the weight force, the force weight. So that's going to be 1 times, it'd be the mass times gravity, so that's 1 times 9.8, roughly. And that gives us 9.8 newtons. The acceleration on the trolley is going to be the same as the trolley and the mass together. So let's rearrange this. We've got A equals F over M. And we can rearrange that, or no, we don't need to rearrange it. We can just put the information in. We have rearranged it from up here. So we could rearrange that to say A equals F over M. Now, I'm just going to put in the bits. A equals the force, which was 9.8, divided by the total weight, or the total mass weight, which is 4. And if we do the maths, that's 2.5 meters per second squared. The weight force of the trolley's got no effect because it's perpendicular to the trolley's direction. Or the trolley, it's perpendicular to the trolley's direction of acceleration. So it's balanced by the reaction force of the bench. His third law is the one that's possibly the most well known, and it says for every action there is an equal and opposite reaction. And the reaction force results from the action force. Often the reaction force is friction, but what we have is that what we have is that the action force acts on one object and the reaction force acts on another. So if we look at the rocket here, we've got there's action, there's hot gases being pushed out, and then the reaction is the thrust. And that's what causes the rocket to take off. The same logic is applied to a balloon. The air's coming out at the bottom and the balloon moves up in reaction.